You calculate DDP again, basically filtering out anything that wouldn't qualify as critical, and then you compare. And you would hope that you are more effective at finding the important bugs, at least if you're focused in the right places. Now, a lot of our clients, unfortunately, when they first go through this exercise with this metric, find that they actually have this relationship inverted, that their overall defect detection effectiveness is higher than their defect detection effectiveness for critical bugs. This is one of the reasons why clients choose to work with us on a number of occasions to get them started doing risk-based testing, because risk-based testing is the thing that's going to help you focus on bugs based both on likelihood and expected impact. And this expected impact, of course, drives criticality. Now, how efficient are we? So my favorite measure of bug finding efficiency is from a technique called cost of quality. If you're not familiar with cost of quality, you can check out J.M. Duran's book, Planning for Quality, I think discusses it. Phil Crosby's book, Quality is Free, discusses it. There's also a discussion in some articles on the RBCS website related to testing return on investment. So there's more details available here for you to read about this and go, ooh, this is cool. Basically, what you're going to do is there are three kinds of costs that are of interest in terms of figuring out the return on investment for testing. There's the cost of detection. This is how much you spend to test that you would spend even if you didn't find any bugs. So basically, it's the time to set up the test, time to plan the test, time to set up the data, time to set up the environment, to get the test team ready, so forth, and of course to execute the tests once. Then you have the cost of internal failure. Now the cost of internal failure is the cost of things like regression testing and confirmation testing that happen after the first test run. Basically, it's every cost that you incur after the first execution of your tests that you wouldn't have incurred if you hadn't found any bugs. It also includes the developer's cost to fix the bug, of course. So we have to include that in there. Now, if we want to calculate the average cost of a test bug, we can calculate the cost of detection and the cost of internal failure, and then divide that by the number of test bugs that we found. That's the average cost. Then you calculate the average cost of a production bug, and that's the cost of external failure divided by the number of production bugs. Now, at this point, you've got two numbers, and so on average, the average cost of a production bug minus the average cost of a testing bug, that's the average saved by testing, or at least the opportunity for savings created by testing. Now, almost always the case that the average cost of production bugs is going to be greater than the average cost of a testing bug. It's really rare for that not to be the case. In fact, I cannot remember ever seeing it during an assessment for a client. So this is going to be some positive number, this average cost of production bugs minus average cost of test bugs. You multiply that by the number of test bugs found, and that's the net benefit of the test team. And if you let's say that the difference between a test bug and a production bug is $2,000. Every bug you find in testing is offering the organization, on average, an opportunity to save $2,000. So if you find 1,000 bugs in testing, then your net benefit is $2 million. Now notice that this is a net benefit because it does include the costs associated with testing and with fixing the bugs that are found by testing. That is being deducted out of there, out of the benefit. So this is a net benefit, not a gross benefit. And if we then divide that by the cost of detection, then that gives us the return on investment, or ROI, because that's how you calculate the return on investment. It's the value, the net benefit received from the investment divided by the cost of the investment, the initial investment made. So the cost of detection is the investment that's made. So where is that number likely to be? Well, we've seen it range quite a bit. Seems like a fairly typical number is about 800%, though it's, well, typical, a median number, let me put it that way, one is sort of in the middle of the range, But it does spread out all over the place. And, you know, I've seen it at 100%, I've seen it at 50%, seen it as high as 3,200%. But 800% seems to be pretty much a median value. So at 800%, basically every dollar spent on testing saves the organization $8, and you know, that's pretty good return. You're not getting that in the stock market these days, especially not after yesterday. It was a bad day. So, as you see there, what we can do is we can look at objectives, we can look at metrics for effectiveness and efficiency, we can establish those metrics, and then we can start to establish goals. So now this is something else that you'd have to say, okay, you know, what is our goal here? And it's important to get people to be realistic about this. You know, you start talking about defect finding, sometimes you get people saying, oh, you know, you found 100% of the defects. Well, that's not connected to reality, right? So there's likely to be some iteration here in this part of the process too, where having established the metrics, you now have conversations with people about, okay, well, what should our goal be for this? What's our target? Now, you know, there are a couple good ways to do this, and you know, we've worked with a number of clients to help them do this, so these work. One of the things that you would want to do to establish goals is benchmarking. So benchmarking is, you know, what's a typical value for this, right? So, you know, try to establish what a typical value would be. And then there's the baselining, right? So baselining would be where you would say, well, where are we right now? You know, so benchmark, you know, comparing your performance against sort of typical industry values. Baseline is where do we currently stand? And then the goal would be something that you would kind of derive out of those considerations, right? Where do we want to go over time? Now, on this thing, this matter of elegance, again, you know, the metrics are going to help you be effective and efficient, and you can use satisfaction surveys and so forth to measure how elegantly you're doing the work. But a lot of this is also about just sort of an ethic, a work ethic, a philosophy of, you know, saying, hey, you know, I don't want it to look like an amateur operation. You know, we are professionals. We're going to act like professionals. We're going to work like professionals. It's going to be a professionally run operation. We're going to do our work in an elegant fashion, right? So, you know, as a manager, if you're a test manager, you got to watch this kind of stuff, right? You know, look at this like, if I were someone looking in from the outside, didn't know what was going on here, would I be impressed or dismayed? Would I think, wow, this guy's really got it together, or would I think, wow, it's amazing that anything good happens in there? Now, one of the things that I find is really important to that is a service-oriented outlook and focusing on what matters. And there's just two things that are really important. The focus on what matters is, you know, being sensitive to the goals and objectives established by the outside as primary, right? And we're going to talk about internal metrics, internal objectives in a minute, but you know, you want to remember that you're there to focus on what matters to the organization, not what matters to you. You know, this is not certainly about being the greatest test geek in the world.